The last step of glycolysis is called ATP formation. Each triose bisphosphate molecule contains two phosphate groups. Since there are a total of two triose bisphosphate from a single glucose, a total of four phosphate group can be transferred from triose bisphosphate to form four ATPs. So again, there are two phosphate groups per triose bisphosphate. There are two triose bisphosphate per one glucose. Therefore, four ATPs can be formed. Now, ADP, they are energetically not active form of ATP. They're called adenosine diphosphate. You need three phosphate groups to make this an active molecule. Therefore, you do need these phosphate groups from to be transferred from triose bisphosphate to ADP to form ATP. Now, after these triose bisphosphate loses both phosphates, they become pyruvate, and because there are two, again, there are two pyruvate as a resulting product of glycolysis, and four ATPs are formed. And if you remember, we already used two ATPs in the beginning of glycolysis. Therefore, net gain of ATP are two ATPs. So going back to the original equation of glycolysis, C6H12O6, that's glucose, that becomes 2-pyruvate. So because, as I said before, it's 6 carbon, that's 3 carbon. 2 NAD, now these were, as I said before, they are oxidizing agents. They carry hydrogen, so that phosphate group can be attached to the triose molecule, and 2 ADP and 2 phosphate group, they join together to form 2 ATPs. So I actually added here a little bit, 2 ATPs. So I mean, they're not, they don't show up in the official, equation, but I just wanted to show that there are a total of 4 ATPs formed, and there are 2 input of ATPs in the beginning of the glycolysis. So that's just to show, that this is a complete glycolysis reaction.